Good morning to everyone. So in fourth unit we are going to discuss about sequential circuit. In third unit we discussed combinational circuit. What does mean by combinational circuit? So combinational circuit is consists of combination of gates. It has no memory and there is no feedback. So we have a different combinational circuit, that is adder, subtractor. So in adder we have full adder and half adder, full subtractor and half subtractor, parallel adder, binary adder. Subtractor we have a full subtractor and half subtractor. And encoder, decoder, multiplexer, demultiplexer, comparator and code converter. So in code converter we have different types of code converter: BCD to binary, binary to BCD, gray to binary, binary to gray, XS3 to binary, binary to XS3. So like that. So in that slide we are going to discuss about sequential logic. So what does mean by sequential circuit? Sequential circuit means it has a memory element and it has a feedback. It depends on the past and present input. Whereas combination circuit, it has only depends present input only. So in that we discussed latches, flip-flops and counters. So in that slide set time. So until now we have essentially ignored the issue of time. So we have assumed that our digital logic circuits perform their computation instantaneously. So our digital logic circuits have been stateless. Once you present a new input, they forgot everything about previous input. So in reality, time is an important issue. Our logic gate include a small amount of delay. So on the order of a few nanoseconds. For much of what we do, we actually want our circuits to have some form of memory. So this is time notation. That is high and low state, high state, low state, and in between the high to low state is transition state. So this slide shows time notation. So here, enter high or low. So X will be first high state and it will be next low state. So again it starts from low state to high state. So in between the time is transition state. So this is NAND latch. What does this circuit do? So this is SR flip flop. So the NAND, here we are using two NAND gate. So the one input, S input will be given to the one of the input of NAND gate, and second NAND gate, the OR output will be, OR input will be given to the second NAND gate. So the output of first NAND gate is Q, so that will be given to the input of the second NAND gate. So the output of second NAND gate is Q bar, so that will be given to the input of the next NAND gate. So here NAND latch, consider this initial state. So S R. So here also we are having two input and two NAND gate. So one input will be given to S and next input is given to R. So again the output is Q and Q bar. The Q is output will be given to the first NAND gate, second NAND gate, and Q bar will be given to the input of the first NAND gate. So suppose if S R which is equal to 1 means, so in this stable state the output is 0, 1. So according to the truth table of NAND latch, NAND gate, so we can consider the output respectively. So what happens? S is set to 0. So S is set to 0 means R will be 1. S is 0 means Q bar will be 0. So again Q will be given to the input of the second NAND gate. So here 0, 1. R gate, R input is 1. Second NAND gate input is 0, 1. So 0, 1 means the output of the NAND gate will be 1. So that will be given to the first NAND gate. So 0, 1. 0, 1 means again 1. So it is stable state. So the next is S which is equal to 0, R which is equal to 1. So 0 transition state to 1, again 1 transition state to 0. So here S which is equal to 0, so that input will be given to the NAND gate. So again Q bar will be given to the input of the first NAND gate. Again R will be given to the one input of the NAND gate. Again Q will be given to the next input of the second NAND gate. So here 1 transition 0, 0 transition 1. So in that NAND latch, now S is set to 1. So what will happen? So S which is equal to 1, R which is equal to 1. So if any input is, that is S is equal to 1. If S is 1 means the output will be high. S which is equal to 0 means the output is 0. It means S which is equal to 1 means the output is set state. So SR means set reset flip flop. S which is equal to 1 means set state, which is equal to 0 means reset state. So here S which is equal to 1 means Q will be 1. So R will be already 1. So Q will be given to the input of next NAND gate means the output will be 1, 1 means the output will be 0. So that is the truth table for NAND gate. So here NAND latch circuit, Q and Q remains the same. That is Q and Q bar remains the same. So Q and Q bar retain a memory of past state. So here S which is equal to 1, R which is equal to 1. S which is equal to 1 means the output will be 1. So here R which is equal to 1. So the output Q will be 1. So that will be given to the second input of the second NAND gate. And Q bar which is equal to 0. So that will be given to the input of the first NAND gate. So 1, 0 means the output will be 1. So anyway S is 1 means the output will be 1. So this is a excitation table or truth table for SR flip-flop, that is set reset flip-flop. So now set R to 0. So the previous case SH is equal to 1 and SH is equal to 1. Now set R to 0. What happens? So SH is equal to 1, R is equal to 0. So the first NAND latch, the input of the output will be Q, that is Q will be 1, Q bar will be 0. So Q is given to the input of the next NAND gate, that is second NAND gate, and Q bar will be given to the input of the first NAND gate. So the output of first and second output will be Q and Q bar.